So welcome back to CIS 123. This is week 10 officially, and we're going to continue look at stack. And I already started my Visual Studio project, and this is what we have in class, so you can follow along if you'd like to write the code along with me. So I'm going to reopen our stack project, which was still unfinished, and there's still work out there to deal with. But before we reopen the stack, what I would like to do is just to create a small temporary project to introduce a new concept, which is C++ references. Okay, so I'm just going to say new project, okay, and create this new project from scratch. First, we're going to spend a few minutes with just looking at the code. So here's my project. This is going to be week 10 references. Okay, this is the way I'm going to call my demo project today, which is going to be our introduction to this week. There's also a handout on our website. Okay, so if you go to CIS web, right, and if you jump to CIS 123 for week 9 or so, there is a handout for C++ references, which is going to summarize the talk that we're going to have. But I'll just write some code instead of going through the presentation. Okay. And by the way, this is what is going to be our agenda today. Continue looking at constructors for classes, different types of constructors, why we need them, and perhaps we're also going to look at the assignment, like assigning one object to another, and things that will be continuously, developing from analyzing those concepts in depth. So here's my brand new project to start with. So the usual stuff is to go to Solution Explorer, go to the source files, and say add new item, and this will be placed under my project under source src. Right, and this is going to be just, as always, plain vanilla main implementation file that contains the main function, right? So make sure that you select the right file type and just click add, so that automatically gets added to the build. We have this file. So the usual routine is to create like just really basic stub for program that does nothing, and then we can experiment with a few new elements today. cstd lib for our pause int main, right? This is a function, and it returns a0 back to the operating system, which indicates everything's fine, and we're going to use system pause command to stop before our window closes, right? So that's just a basic starting point for us right now. Okay, so then we will create this silly integer x equals 1, okay? So if I switch over to like my sketching right here, so this variable x, right, so we have our main function which already got invoked, right? So somewhere in memory main has a variable named x, and this x is just a label that is given to a location of that integer, right? So if I store number 1, what I should place inside the box is the number, right? This is the value, the actual integer value that gets stored in that memory location, right? But x is more like a label, because the compiler will give me access to this value in memory simply by using the variable, right? So if I, somewhere here, if I say x equals 2, right, what's going to happen as a result that this is going to change to 2 and just change the value. Obviously, x is something that isn't going to change. It's just a variable name, and it's not supposed to change, so we can use it freely the way we want. Okay, so interestingly, a kind of strange question. Can have this other names for x, question mark, right? Could we give x other names? And that's a really strange question, because another question is, why would we want something like that? Okay, what if we wanted to give our variable 3 names, like x, y, and z, and all these labels refer to the same integer in memory? It doesn't make much sense, but first, I can tell you that it's possible, right? So let's switch over here, and first I will demonstrate that you can say integer and use ampersand, so y equals x, and then even more so, I can add a z, which I used in the drawing, right? Another label z, it also equals x. Okay, so what's going on? Recall that we had something like this before, which was using a similar syntax. So that should look fairly familiar. If I ask you what pointer is, in this example, you would say pointer is p is a pointer to an integer, and it gets initialized with address of an existing integer variable, which is essentially a very standard way of creating standalone pointer, which refers to a valid location in memory, right? So likewise, when you say integer z equals x, this time we do not use ampersand in front of x. Instead of this asterisk, which in declaration is always a type modifier that says it's a pointer, right? So it's actually a variable that's designed to store addresses of integers. Here, in the same location of the variable declaration z and y, as you can see, I'm using an ampersand. And the way it's interpreted is this. I can actually tell you that z is, and as always, once you found the name or the identifier of the variable, the next you go to the left of this declaration, and this ampersand is pronounced z is a reference. And finally, of course, you look at int and you say a reference to int or integer, right? Z is a reference to integer. Just like over here, P was a pointer to integer, Z is a reference to an integer. Okay, so very similar. The only difference that we didn't have to do anything with X, we just said Z is initialized with X, but the type of Z is using this ampersand, which is pronounced as a reference.